Now we're going to start by graphing y equals 2 because this is one of those graphs that gives people a lot of trouble. And if it gives you trouble today, it's going to end up throwing lots and lots of stuff off. So y equals 2. On your graph there that you're looking at, put a point at any point where y equals 2. So put a dot someplace where the y coordinate is 2. Now, generally speaking, almost everybody will have just put a point on the y-axis up at 2. Okay, that's fine. Now we need another point, because we need to know which way this line is going. We need another point where the y-coordinate is 2. But notice the x-coordinate can be anything. If the x-coordinate was 1 and y was 2, it'd be there. If the x-coordinate was 2 and y was 2, it'd be there. If the x-coordinate was 3 and the y equaled 2, it'd be there. So notice which way this line is going. It is a horizontal line passing through 2. Basically a line at a height of 2. So next up, practicing that idea. Here we got y equals -6. So you should be looking at another horizontal line. This one is at a height of -6. So we should be looking at something that looks like that. Now, we're starting by practicing these simple little y equals a number equations and graphing these horizontal lines because they're going to be immensely useful here in a minute. We're going to be seeing how to graph an equation that looks like this. X minus 3 equals 2. Now, we need to solve it. Now, this that you see up there, that's easy to solve, right? I could do it algebraically. So, like, I could do plus 3, and I could do plus 3, and I could find out that x equaled 5 here. Fine. But what if I gave you something much more complicated, like some of those other equations that were up on the screen when you came in? That's what we're going to see, but we're going to start with this simple example to see how we can handle those. So in order to solve this equation by graphing, what we're really going to do is we're going to treat it as two separate equations. We're going to treat it as y equals the x minus 3 and y equals 2. So above your next graphing grid, please write down this equation as you see it. The x minus 3 equals 2. And now we're going to graph both sides of that equation. So we're going to graph the left side. Now what does the minus 3 do to that graph? Which way does the minus 3 move it? Up, down, left, or right?
Positive. To the right.
It moves it
left. It moves it left because it's not in like a little thing.
Well, you could either see it as moving it down or right. Technically, I would say down because if it were going to be to the right, I'd really put parentheses around it to show that it was in with x. And without those, I think of it as going up and down. So that tells me my first point is going to be down 3. So I put a point down 3. And then I can make my graphs. Because it's y equals x, so that tells me it's a line. So it's going to be over 1, up 1. Put in those points. And then put in enough of them so that you can be really accurate when you break out your straight edge or ruler, whatever you're using, and draw the line in through them. Accuracy is going to matter a lot here. And so because of that, I especially plot the points that are furthest out. So I plot this one that is as far right as I can go up here. And then I plot this one that's as far left as I can go. And so I'm plotting those two especially, then draw the line that goes in between those. And then I go to the graph of y equals 2. Okay? The graph of y equals 2. Remember what that looks like? That's the one we just practiced, right? It is a horizontal line at a height of 2. So draw that in. And when all is said and done, this is what you should be looking at on your graph right now. All right, now that we made the graphs, we can go ahead and find the solution. The solution, notice it says solve for x. So we want to know basically then What x value works in both of these equations to give us the same y value? We graph it so that we can see it visually. It is the point where they cross. What is the x value at that point? It is 5. And so that's our answer, x equals 5. In fact, looking at the graph, you could also know what the y is. We can know that the coordinates to that point are at 5, 2, but this only asks us to solve for x. So we don't need to worry about the rest of it right now. We just need to know that x equals 5. All right, now, having done that one, remember, this was the easy one that we could have solved algebraically as well. We didn't have to go through the whole process of making a graph just to figure out that it was 5. We found it earlier. But why did we do it? I want to give you tools so that you can solve something that looks like this. Now, do we want to solve this algebraically?
No, you.
Probably not. I mean, later this year, we'll actually get to where I give you some tools and you will be able to solve it algebraically. But for now, we don't need to. We can solve it by graphing. We can graph this in order to solve it. So think about how we did the last one. We're going to use the same method. So I'm going to, again, break this up into 2 equations. Y equals the left side, and y equals the right side. Graph those 2 equations both on the same set of axes. All right, so in this case, in order to do this problem, we're going to have to graph both equations. By the way, did you write down the equation above your graphing grid so that you'll have something to look back on later? So I'm going to start by graphing this y equals square root of x plus 2 plus 4. All right, so the plus 2 moves it which way, left or right? It moves it to the left, yes. The plus 4 moves it which way? Up. It does move it up. All right, so I go left 2, up 4, plot a point, and then it's square root. And so this is why you have to know what square root graph does. You have to be able to plot each of those points and make a nice, accurate graph out of it. And so there's our first graph, our square root graph. Now, having done that, I now need to graph y equals 7. So visually speaking, I can just draw that horizontal line across at 7.
Yeah, well, you're using like a thing, so you're cheating. Yeah.
And so now to go on and solve this, remember, I've made the graphs, but that's not actually the solution yet. The solution is all about where do these 2 cross. By making the accurate graph and knowing where it goes through, it lets us know that. If you didn't know what square root did, you'd be in trouble here. So, what is the x-coordinate at this point?
I knew that.
Yes, the x-coordinate here is 7. Now, is that because this was 7?
Yes.
No. It's a mere coincidence that they're the same.
No.
If this whole graph had been moved over or up or down compared to where it actually was in this case, we would have gotten a different answer there.
I am.
And so, in order to solve this, you hopefully have broken it up into these 2 equations. You're graphing y equals negative 1, that's the left side, and y equals the absolute value of x minus 3 minus 5, that's the right side. And you're graphing each of those separately, and then looking to see where they cross. All right, so once you've made your graphs, you should have these graphs, and it says to solve for x. And the x, remember, the solutions are wherever they actually cross. But notice there's actually 2 of them here. What's the x-coordinate at that point on the left? There it's negative 1, so x equals a negative 1. What is the point here? What's the x-coordinate at that point? Looks like that x-coordinate is out at 7. And so we can actually just list the answers like that. We can say x equals negative 1, comma 7. One detail here. There are no parentheses there. Because if I put parentheses around that, then I'm saying one of them's x and one of them's y. That's not what I'm meaning here. I'm meaning that x is both of those. All right, so for this one, once again, we're going to split it up into 2 pieces. We're going to go y equals the left side and y equals the right side. And then we graph each of those. For the first equation, you notice it's x squared, so that tells me it's going to be that U-shaped graph.
Oh yeah.
We put our first point left 1 and down 2. And then we make the same old x squared U-shaped graph that we normally would from there. And then we draw on the line y equals 7, which again is that horizontal line at 7. And having done that, we can now talk solutions. We have two solutions here. They are x equals, well, I'm looking for that x coordinate. So that's -4, yes. X equals -4. And the x coordinate of that point, which is at 2. So our answers are -4 and 2.